Number 1, Joseph ran a 6-mile race in 48 minutes. Which graph has a slope that best represents Joseph's average rate of speed during the race? So we just need to match up the 6 miles in 48 minutes to one of the graphs. A lot of the time on these kind of questions, you can literally just plot this one point. However, on these graphs, this point doesn't fit. So we want to look at our graphs and see how they're labeled. So we have time in minutes on our x-axis. All right, our ordered pairs are x, y, and this is our time in minutes, and our y is labeled with the distance in miles. So what they've given us is 6 miles in 48 minutes. And like I said, a lot of the time you can just plot this point and be good, but 48 minutes doesn't fit on any of these. Okay, so we have to do something else. So this ordered pair here is one of them that if we extended out the graph, it would fit. So we're going to need to simplify this. So on our reference material, when we're dealing with slope, the information they give us is right here, the linear equations. Okay, it does not tell us the constant of proportionality, but the constant of proportionality is when we have y over x. And I know this right here is kind of way confusing, but if you just look at the first part of it, where we have y over x, and you kind of ignore the rest of it, that's going to help you remember that your y always goes on top. Okay, so I'm going to need to find the slope of this line. So here I have my xy, and this is going to be proportional. All right, so my constant of proportionality is y over x, which is going to be 6 over 48. All right, so that didn't fit on my graph, so I want to simplify. Basically, I'm just simplifying a fraction. Okay, so I can divide by 2. If I divide 6 by 2, I get 3 over 24. That's still going to be too big to put on my graph, so I can divide by 3. If I divide by 3, I get 1 over 8. That will fit on my graph. Okay, so this is my slope of a rise of 1 and a run of 8. All right, or you can think of this as an ordered pair, 8, 1. Okay, so either find a slope of 1 over 8 or ordered pair 8, 1. All right, since this is proportional. Okay, so this is my minutes. So on my minutes, 8 minutes, I should equal to 1 mile. That would give me a point right here. That's not on the line, so A is not going to work out for me. B, a point of 8, 1 is on the line, so that looks really good. C, 8, 1 is not on this line, so that's not going to work out for me. D, 8, 1 is on this line, but this doesn't have a slope of 1 over 8. Okay, as a matter of fact, this is going to be an undefined slope. That's not going to work out for me. All right, so the one that is going to work out is B, because my ordered pair 8, 1 fits on there. I have a rise of 1 and a run of 8, because if I start at 0, 0 and make my triangle, I'm going up 1 and I'm going over 8. So B works. Number 2, an oil well contractor drills a shaft 9 meters deeper into the ground every 2 hours. Which graph has a slope that best represents this rate? All right, so we can look at our graphs, because a lot of the time if I just plot this one point, I can get my answer. So we have our meters and hours as our labels. So the hours are on the x-axis, and a lot of time if we just plot this one point, we're good. So the hours is on the x-axis, and then on the y-axis is the meters, the depth. All right, and so what they're telling us is 7 meters So 7 would go here, and the 2 hours would go here. So if I can get this ordered pair to fit, that's a step in the right direction. So this is going deeper, so and we notice all of our numbers are negative. So this is a -7 here. All right, so we want to look at our hours. At 2 hours, can I plot the point -7? Well, we have to look and see what it's counting by. So we're counting by 5s, but we have a halfway mark. So halfway in between 0 and 5 is 2.5. So this is going to be a -2.5. Not going to quite exactly give me a 7 though. But so at 2 hours, I would be, here's my -5. This would be -7.5. So I need to be just a little bit above it right there. So that's not quite on the line. So I need to try another one. Okay, so at 2 hours, and this one's counting, gosh, I don't even know what that's counting by. Okay, this one is counting by 18. So halfway between 7.5 or 17.5 and 18 is a -8.75. So at my 2 hours, I would need to be somewhere right about there. That doesn't work. So F and G are out. So then we have 2 and -7. So here's my -10, here's my -5, and somewhere in between there is my -7. So H is looking good. J is just a straight line. If you're guessing, don't ever pick the one with a straight line. All the slopes we do, some kind of diagonal line. All right, but so, yeah, 2 and -7 is somewhere down here. It's not even on the graph. So J doesn't work. All right, so this one's a little bit tricky because you're counting by different things. We have a negative thrown in. We have all this different stuff going on. But 2 hours, -7 fits right there perfectly for H. Number 3, a company sells bottles of vitamin capsules. The graph and table show the linear relationship between the cost per capsule in cents and the number of bottles ordered. What is the slope of the line that models the situation? Okay, all we're trying to do is find slope. On our reference material, to find the slope of the line, we have this formula, which I know kind of confuses you, but just kind of remember that the y is going to come on top of the x. Okay? All right, so we have two choices here. We have a graph and we have a table. And you know how to do slope. You've done slope, slope, slope. Slope is rise over run. How many up? How many over? Okay, you know how to do that. Okay, so you can use your table here. Pick your perfect points. All right, so perfect points are those that we know what they are representing. So at 2 and 60, that's a great point. Okay, I wouldn't pick this one because that's about 65, but I'm not exactly sure. Okay, 4 and 50, that's a nice perfect point. Make your triangle. Okay, you know how, you've done this a million times. Okay, how many up, how many over? Rise over run. But look and see what you're counting by each time. So I'm going up 1, but I'm really going up 10 because between 50 and 60 is 10. So I'm really going up 10. And I'm running over 2, but I'm really going from 2 to 4, so that is in fact 2. Okay, and 10 divided by 2, that's just 5. All right, no big deal. All right, but this is a line. Okay, this is our slope of a line. And remember, you can draw your little guy on your line. And what's your little guy doing? Okay, he's going down the slope. So that makes this a negative slope. Okay, so some of you just missed this because you didn't put that this was a -5. Okay, but be careful. Okay, you read your graph from left to right. It's going down, our little guy's going down the slope. It's negative. We're rising 10, we're running 2. 10 divided by 2 is 5, negative 5, no big deal. If you want to use the table, you can use the table. You're just subtracting, no big deal, okay? 65 minus 60 is 5. And 1 minus 2, or 2 minus 1, is 1, okay? No big deal. Your y's go on top of your x's. So this is 5 over 1, okay? But we are subtracting 1 minus 2, so that is going to be a negative 1, which is how I get my slope of negative 5. So you have your table, you have your graph, you have lots of ways. Don't freak out. All you got to do is find slope, negative 5.